Hello student, welcome to my channel Learn Physics. Today I will be discussing another JEE main paper February 1st 3 p.m. to 6 p.m. paper. This discussion will be extremely helpful for you to tackle the MCQ in next leg of MCQ exam of JEE main. Okay, now let's start. Now question number 1. Two objects A and B are placed at 15 cm and 25 cm from the pole of a concave mirror having radius of curvature 40 cm. The distance between the image formed by the mirror is. Now look at this. This is a concave mirror. One object look at this, object A is placed at 15 cm from the mirror and another object B is placed. This is the 25 centimeter from the mirror. Okay. And focal length F is equal to 20 centimeter. This is the 20 centimeter. So look at this. A is before the focus and B is after the focus. So this numerical is very easy for you. Now first of all for A. Look at this here, U equal to minus 15. F equal to this is the minus 20. Okay. Therefore, V is the question mark. Suppose this is the V1, this is the U1. So look at this. This is the 1 by V1 plus this is the minus 15 equal to this is the minus 20. So look at this 1 by V1 equal to 1 by 15 minus 1 by 20. Look at this 60 is the LCM. So this is the 4 minus 3. So V1 is equal to 60. Okay. Now in the second case, look at this. In case of 25, look at this. In case of P, U2 equal to minus 25 centimeter. So look at this 1 by V2 minus 1 by 25 equal to minus 1 by 20. So look at this 1 by V2 equals to 1 by minus 20 plus 1 by 25. So this becomes minus 1 by 100. So look at this. This is the real image distance and this is the virtual object distance. So distance between two image is 60 minus 100. So this is the 160 centimeter. Okay. Next. Now question number 2. Figures ABCD shows the variation of force with time. We have to calculate the highest impulse. Now look at this here, force acting at t equal to 0 second, maximum at this point and again 0 at t equal to 1 second. So area of this graph, this is the 0.5 into 1 by 2. So this is the 1 by 4 Newton second. Okay. So impulse in this graph is 1/4 Newton second. Now look at this here, graph is vertically up. So time interval 0. So area of this graph is 0. Now look at this. We have to calculate area of this graph. 0.75 becomes 0 at t equal to 1 second. So area of this graph, this is the half into 3 by 4 into 1. So look at this. This is the 3 by 8 Newton second. Look at this. This greater than this. This graph. Look at this 0 to. Look at this. The force increases 0 to 0.5 in 2 seconds. So area of this graph half into 2 into 0.5. So this is the half. Okay. So look at this, area of this graph is more. Look at this. So figure D is correct. Now what is the option? Look at this. Option C option is correct. Okay. Now assertion reasoning type question. Look at this assertion A. Two metallic spheres are charged to the same potential. B equals to charge Q by 4 pi epsilon naught R. One of them is hollow. Okay. And another is solid. Both solid sphere and hollow sphere both have potential V equals to Q by 4 pi epsilon naught R. Okay. The solid sphere will have lower charge than the hollow sphere. No. Both have same charge. So this is the wrong statement. Okay. Now the capacitance of metallic sphere depends on the radius of the sphere. Yes, this is the correct. C equal to 4 pi epsilon naught R depends on radius. Therefore, assertion false and reasoning correct. Now question number 4. A Carnot engine operating between two reservoirs has efficiency 1/3. Okay. When the temperature of the cold reservoir raised by X, its efficiency decreases to 1/6. The value of X if the temperature of the hot reservoir is 99 degrees Celsius. So T1 equal to, look at this, 273 plus 99. So look at this is the 372. Okay, no problem. Now look at this, the efficiency eta, that is 1/3. This equals to 1 minus, this is the T2 by 372. So look at this is the 2/3 equals to T2 by 370. Okay, now this and this cancel out. So look at this, this is the, so this is the 1 to 4. Therefore from this equation T2 equals to, this is the 248. Now temperature, when temperature of cold junction, when temperature of the sink increased by X, okay, the efficiency becomes 1/6. So look at this, 1/6 equals to 1 minus, this is the 248 plus X divided by, this is the 372. Now look at this is the 5/6, this equals to 248 plus X divided by, this is the 372. Now this and this is the 62. Now look at this is the 248 plus X, this equal, now look at this, 5 into 62, this equal to 310. Okay, so look at this, 52 plus 62, so X equals to 62 Kelvin is the rise of temperature. Now what are the options? Now look at this, option 4 is correct. Okay, now question number 5. The equivalent resistance between the adjacent corner of a regular n-sided polygon of uniform wires of resistance R would be. Now look at this is the n-sided polygon. Okay, look at this is the n-sided polygon. Now we have to calculate the resistance between A and B. Now total resistance R, so resistance of each arm is the R by N. So look at the resistance of this section is the R by N. So resistance of the rest of the section, this is the R by N into N minus 1. So look at this is the parallel combination. So equivalent resistance, this is the R by N into R by N into our N minus 1 divided by, look at this is the R by N plus R by N into N minus 1. Look at this is the obviously R. So look at this is the R by N square into, look at this, R by N square into N minus 1 into R divided by, this is the also R. Okay. Therefore equivalent resistance is the R by N square into N minus 1. Now question number 6. As shown in the figure, a block of mass 10 kg lying on the horizontal surface is pulled by a force F. Look at this is the force F. Acting at an angle 30 degree with the horizontal. Now mu equal to 0.25, the block will just start to move for the value of F. Now look at this, the force F acting along this direction, this is the F cos 30 degree. Okay, now in the vertical direction, look at this, in the vertical direction the force is, this is the F sine, this is the 30 degree. Now normal reaction along this direction and mg in the vertically downward direction. So look at this is the mg. Now force of friction mu n acting along this direction, this is the mu n. So look at this, n plus f sine 30 degree equals to mg. So n plus f by 2, this equal to, this is the mg, mg equals to, this is the 100 Newton. So look at this, n equals to, this is the 100 minus f by 2. Okay, no problem. The block will move if this equal to this. Okay, so look at this is the root 3 by 2f, this is the mu is the 1 by 4, and this is the 100 minus f by 2. Okay, so look at this is the 25 minus f by 8. Okay, so look at this is the root 3 by 2, plus 1 by 8f, this equal to 25. Therefore, look at this, f equal to, this is the 25 divided by, look at this, 1 by 8. So 8 is the this, and this is the 8 root 3 plus, this is the 4 root 3 plus 1. So this is the 4 root 3 plus 1. Now, what is the value of this? Look at this, 25 into 8, this is the 200. Look at this is almost 7. 7 plus 8, okay? So look at this is the almost 25 Newton, okay? Now look at the options. Look at this, here 25.2 Newton is the answer. Now question number 7. For three low density gases ABC, pressure versus temperature graph plotted while keeping the volume constant shown in the figure. Look at this, gas A, gas B, gas C, okay, and temperature in degree Celsius. Now the temperature corresponding to the point K. Oh, look at this. Look at this. This is the absolute zero. Now the value of absolute zero in Celsius scale is the minus 273 degrees Celsius. Okay. Now look at the options. So look at this. This is the option 2 correct. Okay. Now question number 8. An electron of hydrogen-like atom having Z equal to 4 jumps from fourth energy state to second energy state of energy state. The energy released in this process. You know the hydrogen atom have the energy of fourth atom in hydrogen atom. Look at this, the the energy of electron in the fourth orbit of hydrogen like atom, this is the 0.85 into z square. Z square means this is the 4 square. Now E2 equal to, this is the minus 3.4 into z square, that is the 4 square. Uh, so look at this, delta E equal to, this is the E4 minus E2. This is the 2.55 into, this is the 16. Okay, 2.55 into. So look at this is the almost 40. So look at this. So this is the 40.8 electron volt. Okay. Now question number 9. Choose the correct length versus the square of time period graph of a simple pendulum. You know t equals to 2 pi root under, this is the L by G. So t square equal to 4 pi square L by G. So look at this, t square proportionate L. So this is the straight line graph passing through origin. Now what are the options? Look at this, option 4 is correct. Okay. Now look at this question number 10. If the velocity of light c, universal gravitational constant g, Planck's constant h are chosen as the fundamental quantities, the dimension of mass in the new system. Now we know the dimension of velocity is Lt minus 1. G has dimension, this is the m minus 1 L cube t minus 2, and dimension of h, this is the ml square t minus 1. Okay, now this type of numerical will be easy if we put this dimension in this equation. Look at this, we have to calculate the dimension of mass. So look at this, if g to the power minus half and h to the power half, then the m will be obtained. Now look at this, g to the power minus half and h to the power half. Look at these options. Now paste it. Now look at this is the m minus half, this is the L, and this is the t minus half. Okay. Now see, look at this is the L half and this is the t minus half. No problem. Now g to the power minus half. So look at this is the minus half, this is the L 3 by 2, and this is the t to the power minus 1. Now look at this, t to the power minus half, t to the power minus half, and t to the power 1. So this is the t to the power 0. 1. Look at this, L to the power 1, L to the power half, L to the power, this is the minus 3 by 2. So look at this, L to the power 0, and m to the power half, m to the power half. So this is the m. Okay. So look at this, option 3 is correct. Okay. This is the easy way to solve the equation. Now question number 11. The threshold frequency of a metal is f naught. When the frequency of light is 2 f naught is incident on a metal plate, the maximum velocity of photoelectron is v naught. Now look at this. This is the half m v naught square. This is the h 2 f naught minus h f naught. So look at this. This is the h f. Okay. When the frequency of the incident radiation is 5 f naught, velocity is the v2. So half m v2 square. This equals to h into this is the 5 f naught minus h f naught. So this is the 4 h f naught. Okay, so look at this. If this equation 1 and this equation 2, if we divide equation 2 divided by equation 1, we get this is the v2 square by v1 square equal to 4. So look at this, v2 by v1, this equal to 2. Okay, now option 1 is correct. Okay, question number 12. The ratio of average electric energy density and total energy density of electromagnetic wave. You know, the total energy density of electromagnetic wave is equally shared between electric field vector and magnetic field vector. So energy density in electric field is the half of total energy density. So look at this, option 2 is correct. Okay. Now question number 13. A coil is placed in a magnetic field such that plane of the coil is perpendicular to the direction of magnetic field. The magnetic flux through the coil can be changed. Look at this, by changing the magnitude of magnetic field. Look at this, flux equals to phi equals to n b a cos theta. Okay. So look at this, by changing the magnitude of magnetic field within the coil. Okay, this is the correct option. By changing the area of the coil within the magnetic field, this also correct. By changing the angle between the direction of magnetic field and the plane of the coil, this also correct. Okay, by reversing the magnetic field direction abruptly without changing magnitude. No, here not changes flux. So look at this, here option A, B, C are correct only. Okay, now question number 40. In young modulus of a steel wire of length 6 meter, cross-sectional area 3 millimeter square is 2 into 10 to the power 11 Newton per meter square. The wire is suspended from the support on a given planet. A block of mass 4 kg attached to a free end of the wire. The acceleration due to gravity on the planet is 1/4 of its value on the earth. The elongation of the wire. Look at this, the elongation of the wire L equals to, this is the MGL by, this is the AY. Here G is the G dash. Okay. Now what is the M? M equals to 4 into G is the 1/4 of 10. What is the L? L is the 6. Now what is the A? A is the 3 into 10 to the power minus 6 meter square, and Y is the 2 into 10 to the power 11. Okay. Now look at this. This and this cancel out. So look at this. This is the 60 divided by, this is the 6 into 10 to the power 5. Okay. So look at this. This is the 10 to the power minus 4 is the elongation. Now 10 to the power minus 4 meter, this is the 0.1 millimeter. Okay. Now question number 15. For a body projected at an angle with the horizontal from the ground, choose the correct statement of option 1. The vertical component of momentum is maximum at the highest point. No. The momentum is highest at the point of projection. The gravitational potential energy is maximum at the highest point. Okay. The gravitational potential energy maximum when h is maximum. So at the maximum height, gravitational potential energy is maximum. Okay, option 2 correct. Now question number 60. In the amplitude modulation, a modulated signal having amplitude x volt is superimposed with the carrier signal of Y voltage in first case. Then in second case, the same modulating signal is superimposed with different carrier signal of amplitude 2Y. The ratio of the modulation index. Now look at this, modulation index equals to amplitude of the modulating signal divided by amplitude of the carrier wave. So modulating signal is the x, amplitude of modulating signal is the x, and carrier and amplitude of carrier wave is y in the first case, and in a second case this is the x by 2y. Okay, so ratio between this is the mu1 is to mu2. So this is the 1 is to half. So this is the 2 is to 1. Now what are the options? Look at this. Option 2 is correct. Okay. Now assertion and reasoning type question. Assertion A. For measuring the potential difference across the resistance 600 ohm, the voltmeter with resistance 1000 ohm will be preferred over a voltmeter of resistance 4000 ohm. No, 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 no. This is the greater the resistance of the voltmeter, the more accurate is the measurement. So this is the wrong statement. The voltmeter with higher resistance will draw smaller current than voltmeter with lower resistance. The voltmeter with higher resistance draws smaller current than the voltmeter with lower resistance. Okay. Greater the resistance of the voltmeter, lower will be the current passed through this. Okay. Look at this option 2. Assertion is not correct, but reason is correct. Okay. Question number 18. The escape velocities of two planets A and B in the ratio 1:2. So VE by VE dash is the 1/2. And ratio of the radii, look at this. This is the R by R dash. This is the 1/3. Okay. And ratio of the accretion due to gravity on the planet A to the planet B. Now look at this. You know VE equal to root over 2GR. Okay. Now look at this. So G proportional to equal to VE square by R. Okay. So look at this. G by G dash. This equal to, look at this. This is the V by VE dash whole square into R dash by R. Now look at this. This is the, look at this. This is the 1/4. Okay. And R by R dash. So look at this. This is the 3. So our ratio is the 3/4. Okay. Look at this. Option 1. Look at this. The option 1 is. Now question number 90. Choose the correct statement about Zener diode. It works as a voltage regulator in reverse bias, correct, and behaves like a simple PN junction diode in forward bias. Okay, no problem. This is the correct option. Question number 20. As shown in the figure, a long straight conductor with semiconductor arc of radius pi by 10 meter is carrying a current I equal to 3 ampere. The magnitude of magnetic field at the center of the arc is. Look at this. This is the semicircular arc. So B equal to, this is the mu naught I by 4R. Okay. Now put the value. This is the 4 pi into 10 to the power minus 7. I is the, look at this is a 3 ampere, and this is the 4. R is the, look at this is the pi by 10. Okay. So look at this 4 pi cancel out. So look at this is the 3 into 10 to the power minus 6 Tesla is the magnitude of magnetic field at the center. Okay. So look at this 3 micro Tesla is the correct option. Okay. Now look at this question number 21. This is the numerical type question. Now the surface of water in the tank of cross sectional area, this is the 750 centimeter square on each meter above the tap level. The speed of water coming out through the tap of cross sectional area 500 millimeter square is 30 centimeter per second. At the instant dH by dt equals to x into 10 to the power minus 3 meter per second. The value of x is. Now look at this. This numerical is very easy for you. If we apply the equation of continuity, then you get V1 A1 equals to V2 A. Now what is V1? Now V1 is equal to, this is the dH by dt. Now A1, so look at this, this is the dH by dt. Now what is the value of A1? So this is the 750 centimeter square. Now V2, look at this, V2 is equal to, look at this, this is 30 centimeter per second. Okay, this is the 30 centimeter per second. Now what is A2? Look at this, this is the 500 millimeter square. So this is the 5 centimeter square. Now this and this cancel out. So look at this dH by dt. This equal to, this is the 1/5. This is the centimeter per second. So this is the 0.2 into 10 to the power minus 2 meter per second. So this is the 2 into 10 to the power minus 3 meter per second. So x is equal to 2. Okay. Now question number 2. The moment of inertia of a disk of mass m and radius r about any of its diameter is m r square by 4. The moment of inertia of this disk about its normal to the disk and passing through the point on its edge will be, look at this. This is the disk. Okay. You know the moment of inertia about this axis. Okay. Now, moment of inertia about an axis normal to the plane equal to, look at this. This is the half mr square. Okay. So moment of inertia of this about this axis is equal to, look at this. This is the half mr square plus mr square. So this is the 3 by 2 mr square. Okay. Now this is the x by 2 mr square. So here x is equal to 3. Now question number 23. Nucleus A having Z equal to 17 and equal number of proton and neutron has 1.2 mega electron volt binding energy per nucleon. So look at this. Here atomic number A is equal to, this is the 17 plus 17 is equal to 34. And binding energy this equal to, this is the 1.2 mega electron volt. Another nucleus B has Z equal to 12 and total 26 nucleons. So number of nucleons, that is the A is equal to, this is the 26. Okay. And binding energy this equal to, this is the 1.8. Okay. Now difference of binding energy delta E, this is the 34 into, this is the 1.2 minus 26, this is the 1.8. Now 0.6, look at this. This is the 34 into 2 minus, this is the 26 into 3. Okay. Now look at this. 0.6, 34 into 2, this is the 68, and 26 into 3, so this is the 78. Therefore this is the 10. So 6 mega electron volt is the difference of binding energy. Okay. Question number 24. For a train engine moving with a speed of 20 meter per second and driver must apply brake in before the station for the train to come to rest at the station. If the brakes were applied the half of this distance, the train engine would cross the station with a speed of root x meter per second, the value of x. Now look at this. This is the half mu square. This equal to, this is the 2 into a into s. S is the 500 meter into mass. Now in the second case, this is the half mu square. Okay. Minus, this is the half mv square. This equal to, this is the 2 into a, s is the, this is the 250 into, this is the m. Okay. Now this value is the half of this. So look at this. This is the half mu square minus half mv square. This is the half into half mu square. No problem. So look at this. This is the half mv square. This equal to, this is the half mu square minus, this is the 1/4 mu square. So look at this. This is the v square equal to u square by 2. So look at this. This is the v equal to, this is the u. So look at this, v equal to u by root. Okay. Now look at this. U is equal to, look at this. U is equal to 20 meter per second. So this is the 10 root. Now 10 root 2 equals to root over of 200. Therefore x equals to 200. Okay. Now question number 25. A force F equal to 5 plus 3y square act on a particle in the y direction, where F is Newton and y is in meter. The work done by the force during the displacement y equals to 2 meter to y equal to 5 meter. You know work done by the variable force y equals to, this is the F dy from limit 2 to 5. Now what is the F? f is the 5 plus this is the 3y square into dy, and limit of integration this is the 2 to 5. So look at this is the 5 into this is the 5 minus 2. Now this is the 3y square dy. So look at this is the y cube, and limit of integration this is the 5 and 2. So look at this is the 5 into 3 plus, look at this is the 1 to 5 minus 8. So look at this 15 plus this is the 117. So look at this is the 132 is the work done. So this is the 132 joule. Okay. Now question number 26. As shown in the figure, in young double slit experiment, a thin plate of thickness 10 micrometer and refractive index mu equals to 1.2 is inserted in front of a slit. The experiment is conducted in air mu equal to 1 and uses the monochromatic light of wavelength 500 nanometer. Due to the insertion of the plate, the central maximum shifted a distance of x beta naught, where beta naught is the fringe width before the insertion of the plate. Okay, now the value of x. Now x beta naught, this equal to, this is the mu minus 1 in equal to beta naught by lambda. Now beta naught and beta naught cancel out. This is the t into mu minus 1. Now t equal to, look at this is the 10 micrometer, 10 into 10 to the power minus 6. Mu is the 1.2 minus 1 and lambda is the, this is the 500 into 10 to the power minus 9. So look at this is the 2 into 10 to the power minus 6 and this is the 5 into 10 to the power minus 7. So look at this, x is equal to 4. Okay. Question number 17. In the given circuit, the value of I1 plus I3 plus I2 is. Now look at this is the, look at this is the I1 current. Now if we apply this loop, this, we can get. Look at this is the 10 into I1 equal to 10. Therefore I1 equal to 1 ampere. Now if we apply this circuit, look at this circuit, this, then this loop. Okay. So you get, look at this, 10 into I2 equals to 10. So look at this, I2 also 1. Now if we apply, look at this, if we apply this loop, this and this loop, outer loop. So look at this is the plus 10 into I3. Now look at this, from here this is the minus 10. Now this is the plus 10 minus 20, this equal to 0. So I3 is also 1. Now I1 equal to 1 ampere, I2 1 ampere, I3 also 1 ampere. So look at this, 1 plus 1 by 1. So this is the 2. Okay. Now question number 26. A square-shaped coil of area 70 centimeter square having 600 turns rotating a magnetic field 0.5 Weber per meter square about an axis which is parallel to one of the side of the coil and perpendicular to the direction of the field. If the coil completes 500 revolutions in a minute, the instantaneous EMF in the plane of the coil inclined at an angle 60 degree will be. Now look at this, the instantaneous value of EMF. This is the N, B, omega A. This is the sine omega T. Okay. Now look at this. This is the N, number of turns. This is the 600. Okay. Now B is the 0.4. Okay. Omega, look at this. Omega is the 500 revolution per minute. Now 500 revolution per minute, that is 500 by 60 is the revolution per second. So look at this is the 12. Now look at this is the 12 revolution per second. So omega is the 24. Okay, pi. Now A is the, look at this, 70 centimeter square. So 70 into 10 to the power minus 4. And this equal to, look at this is the 60 degree. So this is the root 3 by 2. Okay. So this is the 240 into, this is the 24 pi into this is the 70 into 10 to the power minus 4 into 0.866. Okay, no problem. Now look at this. This is the, now look at this. This is the 0.7 and this is the 2.4. So look at this, 2.4 into 24 pi. This is the 0.7 into 0.866. Okay, this equal to almost 110 volt. Okay, next. Now question number 29. A block is fastened to a horizontal spring. The block is pulled a distance x equals 10 centimeter from its equilibrium position on a frictionless surface from rest. The energy of the block at x equals to 5 centimeter. This is the 0.25 joule, the spring constant. Now look at this, half k x square equal to, this is the 0.25 joule. So look at this, half into k into 5 by 100 whole square. This is the 0.25. So look at this, k equal to, this is the 0.5 into, this is the 400. Okay, so look at this, 200 Newton per meter is the value of k. Okay, now question number 30. A cubical volume bounded by the surface x equals to 0, x equals to a, y equal to 0, y equal to a, z equal to 0, z equal to a. The electric field is given by E equal to E naught x I cap. E naught is given, x equals to 2 centimeter, the charge contained in the cubical blocks. Now look at this, the charge contained in the cubical blocks q into this, the value of q. Now look at this, the q by epsilon naught, this equal to, this is the, look at this is the phi 2 minus phi 1. Now phi 2 is the, look at this is the E2 into A2 minus, this is the E1 into A1. Okay, now E2, what is E2? E2 equal to, this is the E0 into A. A2 is the A square and this is the 0 into A square. So look at this is the E0 into, this is the AQ. Okay, now what is E0? This is the 4 into 10 to the power minus 4. A cube, look at this, A is equal to 2 centimeter. So look at this, 2 by, this is the 100 cube. Okay, so look at this is the 32 into 10 to the power. Look at this is the, now 10 to the power. Look at this is the 10 to the power 6. So 10 to the power minus 2. Okay, now Q equal to, look at this is the 32 into 10 to the power minus 2 into epsilon naught. This is the 8.85 into 10 to the power minus 12. Okay, this equal to 9. Okay, so look at this is the 10 to the power minus 2 and 10 to the power minus 12. So this is 10 to the power minus 40. So this is the 32 into 9 is the value of Q. This is the 288 is the magnitude of value of Q. So this is the 288. Okay, many thanks for watching this video. This video will be extremely helpful for next main examination. To get the better percentile in JEE Main, always connected with my channel. Okay, thank you.